your test will be very much like this review, and the instructions will be like this. It simply says factor completely. If you encounter a polynomial that can in no way be factored, then you need to write down prime, or capital P would be fine, just like in my math lab. Okay, the first one. I'm going to time out just a second. Okay, problem number 1. Look at it. First thing you should ask yourself, is there a common factor? X squared minus x minus 40, the answer is no. The second thing you do is classify it in your mind based on how many terms there are. There are only 3. This is a trinomial. Trinomials are factored by, hopefully, trial and error. Okay, the signs. If the last sign of the trinomial is negative, you always get one positive and one negative. Okay, so that's just a rule. If the last sign is negative, you always get one of each. Well, the first term's pretty easy. It's got to be x times x. Now, I need factors of 40. Now, since this is a plus and a minus, I'm looking for a difference of an implied negative 1. So let's think about the factors of 40. For 40, what do I have? 1 times 40. Do those have a difference of 1? Well, no. 2 times 20? No. 3 doesn't go into it. 4 times 10? No. 5 times 8? And actually, that's the entire list. Do any of those sets of factors have a difference of 1? No. Then what is your answer for this one? Prime. It really feels awkward for answer number 1 to be prime. And yet, these are randomly distributed. There are about 5 primes in here. You just never know where they're going to be. Let's look at problem number 2. I have 3x plus 18 plus xy plus 6y. I can try to make it larger. Yeah, a little bit. All right. Is there a common factor to all terms? No. There are 4 terms. What technique do we use with 4 terms? We use grouping. So here's a group and here's a group. What's the common factor in the first group? 3. So I will factor out a 3. If I divide 3 into 3x, I get x. If I divide 3 into 18, I get 6. So I have 3 parentheses x plus 6 for the first group. What's the common factor in the second group? Y. And since the first term of the group was positive, it's a positive y. If I divide y into the first term, I get x. If I divide y into the last term, I get 6. If you've done it correctly, you will have matching binomials, if it's correct. And it is. So factor that out as your first factor, x plus 6. What is the leftover factor? 3 plus y. And that's your answer. Is that okay? All right. Let's look at number 3. The first question on every single factoring problem is there a common factor? Okay, if I look at 21, 24, and 30, is there a number that goes into all of those? 3. Now, do all of the terms have m's? Yes. What is the power that I can take out? M to the second, because I have to take the low power. So the greatest common factor is 3m to the second. Now, it's a little hard for me to actually put it under here, but if I divide the first term by 3m squared, the 3 goes into the 21 7 times. If I have m to the 8th over m to the 2nd, I subtract and get m to the 6th. Next term, 3 goes into 24 8 times. Subtract your exponents, m to the 4th. And finally, 3 goes into negative 30. negative 10 times, and the m squared over m squared completely cancels out, and I'm done. Well, let me say something. Sometimes after you factor out a common factor, then this might be a trinomial you can factor further. But with this being an exponent of 6 and this being an exponent of 4, that's not the pattern that we did. We did patterns where it was squared and then the plain old m and then the constant. So this is completely finished. It has been factored. All we could do was greatest common factor. Is that okay? Problem number 4. Is there a common factor to the two terms? No. All right. It's a binomial. There's only one kind of binomial that we studied, and it was the difference of squares. Is this a difference? And is it a difference of a perfect square minus a perfect square? And the answer is yes. How do you factor it? Well, you factor it into a sum and difference product. One of them plus and one of them minus. The square root of z squared is z, and the square root of 25 is 5. Make sure that you're taking square roots, not taking half of something. You probably wouldn't be tempted with a 25, but people are tempted sometimes with even numbers. But it's square roots. Number 5. By the way, I'm not taking time to check each one of these, but I would check them by doing multiplication. Do FOIL, whatever it takes to check it. Problem number 5. Do you see a common factor in all the terms? No. It is a trinomial, so I'm going to do my trial and error. When the last sign is positive, both signs match the middle term. So they are both pluses. So remember the rule. If the last sign is positive, they both match the middle term. If the last sign is negative, you always get one of each. So I'm going to have, to get a z squared, I know I need a z and a z. I need factors of 16, which add up to be 8. So could it be 1 and 16? And I have that off the screen. Could it be 2 and 8? Could it be 4 and 4? Yes, those add up to be 8. So I will choose 4 and 4. And then you should check that by doing FOIL. Okay? Any questions? All right, let's look at 6. I have x squared minus 15x plus 54. Do I have a common factor all the way across? No. All right, so it is a trinomial, so I'll go with trial and error. The last sign is positive, which means what? The middle dictates. Minus, minus. Okay? To get an x squared, I need an x times an x. These are both negative, so my factors need to add up to be 15. When the signs are different, you're looking for a difference that gives you the middle term. But these are the same, so I'm looking for a sum. All right, is it 1 times 54? No. Is it 2 times 27? No. Is it 3 times 18? No. 4 doesn't go in there, 5 doesn't go in there, 6 goes in there 9 times. Is it 6 times 9? Yes. Because the outer product is negative 9x, the inner product is negative 6x, those add up to be negative 15x. It does not matter. When the signs are 1 plus and 1 minus, then it matters. All right, let's look at number 7. What is the first question you should ask yourself when you're doing a factoring problem? Is there a greatest common factor? Is there a common factor? And what's the answer in this question? Yes, 5. So I will factor out a 5. If you divide the first term by 5, you will get x squared. If you divide the second term by 5, you'll get minus 9x. And if you divide the last term by 5, you'll get 20. Now, this trinomial is of the form that we've been practicing factoring because it has an x squared and a something x and a constant. So I'm going to go a little further. I'm going to keep the 5. Please don't lose the 5. And I'm going to see if I can do something with this trinomial. The last sign is positive. So what does that tell you? The middle term dictates they're both going to be negative. I know I need an x and an x. I need factors of 20 that add up to be 9. Do we know what they are? Okay, if I had 10 and 2, 10 and 2 won't add up to be 9. So always, if you want to try them, that's absolutely fine, but be sure you check it. So how about 4 and 5? Those do add up to be 9, so I'll put in the 4 and the 5. The outer product is negative 5x, the inner product negative 4x. That adds up to be negative 9x. Then you could distribute the 5 to see that you got that right. The only correct answer is an answer that includes all of those. Don't leave the 5 off. All right, number 8. It's a little bit squished. It is z squared minus 4. Is there a common factor? No. So it's a binomial. The only kind we know is the difference of squares. Is this the difference of squares? Yes. And a difference of squares factors into a sum and a difference product, square roots. Square root of z squared is z. Square root of 4 is 2. Number 9. It's a trinomial. I look across. There's no common factor, so I go straight to trial and error. You really only have 4 things. Greatest common factor, grouping, trial and error, difference of squares. Okay, tell me about the signs in this one. Since that's a plus, middle term dictates, both plus. Need an x and an x. I need factors of 56 that add up to be 15. What would they be? 8 and 7. Now, there is no problem with you listing all of the pairs. 1 and 56, 2 and 28, blah, blah, blah. But if you think of the right ones first, double check it. X times x is x squared. Outer product 7x, inner product 8x, which add up to be 15x. 8 times 7 is 56. All right, number 10. It's 4 terms. I really immediately start thinking about what process? Grouping. So group, group. What's in common in the first group? 8. So I'm going to have 8 times, 8 goes into 8x, x times, 8 goes into 80, 10 times. What's in common in the second group? Y, and it's a positive term right here, so I'm going to use a positive y, plus y, and y goes into the first term, x times, y goes into the second term, 10 times. If I've done grouping correctly, then I get a common binomial, which I did. And that gives me x plus 10 times, what's the other factor? 8 plus y. You can check it with FOIL. The product of the first is 8x. It's right there. The outer product is xy. Well, it's down here, but it's still around. The inner product is 80. It's right there. The product of the last is 10y. So all terms are there. They're just not in the same order that I got them. Are we okay with the first 10? Okay.
So if you did like that last mistake, you would turn it off, would you?
If you,
Or would you?
oh, no, not at all. There's no problem. If you had y plus 8, oh, I'm sorry, you can't see it. If you had y plus 8 instead of 8 plus y, it's fine. Okay, problem number 11. I look at this. Is there a common factor? 4 is the numerical common factor. What about a common variable? X to the 5th. Now, because of room, I don't really have room to write that under each term, which you might want to do. But 4 goes into 4 once, so I don't need to write that. I have x to the 7th over x to the 5th, which is x to the 2nd. 4 goes into 28 7 times, and it's negative. Subtract the exponents, I get plain old x. 4 goes into 40 10 times. The x's completely divide out. Now that's the first step of factoring, and it might be the only step of factoring. But then again, look at the trinomial that we have right here. Does that look up the pattern of trinomials that we factor? And the answer is yes. So I'm going to keep the 4x to the 5th, and I'm going to put parentheses. The last sign is positive, which means middle term dictates, both minus. So I have an x and an x. Can you think of two numbers that multiply together to give you 10 and add up to give you 7? 5 and 2, and it doesn't matter which one you put first or second. Yes?
So when you pull that out, that would be because it looks like on the bottom, it looks like x minus 5 and then x minus 2. But those, if you multiply the minus 5 minus 2, would give you positive 10.
And it does, but that is a positive 10. And then, as your last part of factoring, you would distribute the 5x to the 5th to the positive 10 to get the positive 40x to the 5th. But you should get a positive 10.
And the 2x is negative 5 plus negative 10.
Yes. Mm-hmm. All right, let's look at 12. Is there a common factor to all the terms? No. So I go straight to trial and error. The last term is positive, which means I need the middle term to dictate. I need a plus and a plus. I'm going to have an x and an x. Now, I don't just wake up every day knowing all the factors of 88, so maybe I have to think about it a little bit. But whatever I get, they have to add up to be 87. So 1 times 88. No, those add up to be 89. 2 times 44. No, that took a drastic shift downward. That's only 46. 3 doesn't go into it. 4 times 22. No. 5 doesn't go into it. 6 doesn't. 7 doesn't. 8 times 11. That's actually all the factors of 88. Do any of those add up to be 87? So what do you know about number 12? It's prime. It's a little unsettling, I think, when you get a prime because you don't have something that you can do FOIL and check. You have to be confident enough that you've explored all the possibilities and they simply don't work. And I will tell you how many primes will be on your test. No matter what version of the test you get, everybody has the same number of primes. You just don't know if it'll be number 1 or whether you'll get 3 in a row or what, because they're randomly scattered. All right, number 13. Whoops. All right, is there a common factor? Have you listened and every single problem I've started out saying, is there a common factor? All right, please think about that. All right, the answer is no. It's a trinomial, so I go straight to trial and error. What happens when you have a last term that's negative? Always one of each. The only way to get a negative 63 is to multiply a positive times a negative. All right, x and x. I need factors of 63 that have, because the signs are different, a 1, a negative 1, when I take their difference. Okay, 63. Is it 1 times 63? Do those have a difference of 1? No. All right, 2 doesn't go into it, but 3 times 21. Do those have a difference of 1? No. What is going to work? 4's not, 5's not, 6's not. How about 7 times 9? Do those have a difference of 1? Are there any more factors of 63? That is another prime. Really bothersome, especially you're taking a test, you get 2 primes in a row. There is no rhyme or reason to it. I let the test generator just throw them in. So like I said, you could start out and problem 1 and 2 are both prime. Or they might be evenly distributed, who knows? If I had put them in order, they would have been evenly scattered throughout here. But I let the test generator do it. Okay, let's look at 14. Is there a common factor to all 3 terms? No. So it's a trinomial. And the last sign is positive, which means both signs match the middle term. I'm going to have a z and a z. Well, there's only one way to get a product of 1, and that's 1 times 1. Will that add up to be 2? Yes. So that's my only choice, and it's the right answer. Number 15, is there a common factor? Nope. It is a binomial. Is it the difference of squares? Yes. Now, please be careful on this. We know it's going to be a sum and difference product. Somebody get the door. I'm going to need a z and a z. What's the square root of 64? 8. Don't take half of it, take its square root. And then check that with FOIL. Product of the first is z squared. Outer is negative 8z. Inner is positive 8z. Those cancel. Positive 8 times negative 8 is negative 64. If you're going to take the time to check a problem, then check it being concerned about whether it's right or wrong. Don't just give it lip service and say, yeah, and 5 times 5 is 36. Okay, what I'm saying is don't just expect it to be right. Check it critically. Is 8 times 8 64? Yes, it is. But what if you had 32 and 32? Is 32 times 32 64? No. So what I'm saying is if you're going to take time to check it as if you expect something could go wrong. Hopefully it won't. But don't just blah, blah, blah through the problem. All right, let's look at 16. Is there a common factor? No. The only kind of binomial that we know how to factor is the difference of squares. Is 64k squared a perfect square? Yes. Is it a minus? Yes. Is 49m squared a perfect square? Then it's the difference of squares. 1 plus, 1 minus. What's the square root of 64k squared? 8k. So that goes in both spots. What's the square root of 49m squared? 7m. And that goes in both spots. And then check it. Number 17. Is there a common factor? I think there's not. It's a binomial. Is it the difference of squares? Yes. So I'm going to have 1 plus and 1 minus. What's the square root of 25k squared? 5k. And what's the square root of 49m squared? We just answered that question. So you can see that that wasn't the best plan because 16 and 17 were so similar. That's the way the test generator goes sometimes. Number 18. What's my first question? What is the greatest common factor? Do you think, is there one? You might have to get your calculator out. Does 4 go into 68? The answer is yes. Does 4 go into 288? Okay, so is there a common factor of something to do with the x? Okay, so I'm going to use 4x squared. 4 goes into 4 once. X squared divided into x to the 4th. Subtract the exponents for x squared. 4 goes into 68. 17 times. Subtract the exponents for x. How many times does 4 go into 288? 72. And the x's completely divide out. Look at the trinomial that you have. Does it look like the kinds of trinomials that we know how to factor? The answer is yes. So I'm going to give it a try. Keep my 4x squared, put my parentheses. The last sign is positive, which means both signs match the middle term. Keep an x and an x. I need factors of 72 that add up to be 17. Anything come to mind? 9 and 8. It is absolutely fine if you said 1 times 72. No, that didn't work. 2 times 36. No, that didn't work. And so on. 72 has a lot of factors, but this is the only one that works. It has a lot of factors. Is that okay? 19. Is there a common factor? Nope. It's a trinomial. So here I go. When the last sign is negative, what do I do? One of each. Okay. I have x times x. Now I need the factors of 45 that have, because there's a plus and a minus, a difference of an implied 1. So is it 1 times 45? No. Is it 5 times 8? Are there any more factors? Oh, I'm so sorry. Okay, yeah, I got a little creative there. 5 times 8 is not usually 45, but I was trying to be a little different today. A little wrong. Oh, I'm sorry. 5 times 9, the answer's still the same. It still doesn't work. Even when the numbers are right, it doesn't work. Are there any more factors to 45? There aren't any more choices. They didn't work, so it's prime. That's an embarrassing case where I could have been wrong and still gotten the right answer. So, but don't do that. Don't make up your own multiplication facts. All right, number 20. Is there a common factor? X. All right, so I'm going to factor out an x. When I factor it out, I'm subtracting exponents. So I'm going to get x to the second plus 18x plus 81. Does that trinomial look like something we've factored? And the reason the answer is yes is that you have a squared term, a x term, and a constant term. And when you have that pattern, you should try trial and error. Keep the x. I know, tell me about the signs. They're alike and they're both plus. I have an x and an x. Can you think of factors of 81 that add up to be 18? 9 and 9. And although I have not checked all of these using FOIL, I guarantee you if this is my test, I would. You can either check it immediately or you can do your test and then go back and check it when you're not so, convinced that's the right answer. There are several ways you could test on this. You could go through and do all the binomials first, difference of squares. Then you could go through and do all the grouping, the 4 terms, and then go back and do all those with trial and error, although some of them will have greatest common factor before the other. Or you can just start at 1 and go through, and for some reason, the test has 19 questions instead of 20. I don't know why. Is there anything else? Pardon? Yes, I'll be glad to check that one by FOIL. Okay, if I scoot it up just a little bit. Okay, if I were going to check it, and I'm going to check it in blue, I would do this part first. The product of the first is x squared. The outer product is 9x, but the inner product is also 9x, and the product of the last is 81. Taking that just a little bit further, I know that for the product of these two, I get x squared plus 18x plus 81. Now, that tells me that my last type of factoring was right. But if I want to check the whole problem, I have to bring down the x and then distribute. X times x squared gives me x to the third. X times 18x gives me 18x squared. X times 81 gives me 81x. And that is what I started with.